shaking when the morning crew takes their positions. Rolling mills thunder in sequence. Steam hisses through iron pipes bolted high in the rafters, and the air carries the permanent smell of hot metal and coal smoke. Workers shout to each other across the floor, but the noise swallows their voices before the words arrive. At the center of all of it sits a machine most of these men will never see directly, a massive high-pressure steam boiler. It powers the pumps, the furnaces, the rollers, the valves that move molten steel from one end of this mill to the other. Nothing runs without it. Inside the vessel, water presses against steel walls under crushing force. The temperature climbs without pause. The pressure follows. This boiler has not rested in years. Day shift. Night shift. 12 hours at a stretch. Maintenance deferred. Inspections completed on paper, not in practice. Production quotas do not pause for inspections. The steel shell has been failing slowly, scale accumulating on interior walls, microscopic cracks spreading through metal that was never meant to run this hard for this long. The warning signs exist. No one with authority to stop production is looking for them. Then the men nearby hear something that has no name in their daily vocabulary, a low metallic groan, deep and resonant, like iron being bent past its limit. The boiler ruptures in under a second. Superheated water becomes steam instantaneously. Steel plates tear apart. Rivets shear free. The force that was powering a steel mill is now moving through the men who ran it. When the air clears, 146 workers are dead. Most never understood what was happening. The question is not whether this mill was dangerous. The question is who knew and what they chose to do with that knowledge. America at the turn of the 20th century is being remade from the ground up, and the material doing the remaking is steel. Railroads push across the continent. Bridges span rivers that once stopped cities from growing. Skyscrapers begin their climb into urban skylines. Every beam, every rail, every engine component originates inside mills like this one, vast, deafening, relentless. By the early 1900s, American steel production has become one of the largest industrial enterprises on Earth. Hundreds of thousands of workers report for their shifts inside these facilities, day and night, without pause. Powering nearly all of it is steam. Before electricity reaches the factory floor, steam boilers are the engines of industry. Coal burns beneath enormous iron vessels packed with water. Heat climbs. Water becomes steam. Pressure drives pistons, turbines, and rolling mills. The technology is effective, and it is merciless. A standard industrial boiler operates at temperatures exceeding 300 degrees Celsius, under pressures that would destroy an uncontained vessel instantly. Engineers of the period understand this. Newspapers of the late 19th century carry occasional reports of boiler explosions that level factory buildings and kill dozens of men in a single moment. Some engineers describe poorly maintained boilers in direct terms. Pressurized vessels operating beyond their limits are not equipment. They are deferred disasters. Production does not slow. Boilers run for years without full inspection. Safety valves exist on paper and sometimes in practice. Maintenance is scheduled around output, not risk. For the men working the floor, the boiler room is simply background noise. Heat, vibration, the low constant rumble beneath everything. They do not think about the pressure building inside those iron walls. Most of them never get the warning they deserve. A steam boiler looks, from the outside, like something built to last forever. It is a massive steel cylinder, solid and imposing, anchored to the mill floor with the permanence of architecture. Nothing about its exterior suggests what is happening inside. Inside, water surrounds a network of fire tubes. Burning coal drives the temperature upward. The water boils. Steam collects in the upper chamber and builds pressure that travels outward through pipes, driving the engines and rollers that keep the entire mill alive. The principle is straightforward. The forces involved are not. Industrial boilers of this era operate at pressures exceeding 100 pounds per square inch, pressing outward against every riveted seam and every inch of plate steel. 3 safeguards stand between controlled operation and catastrophic failure: pressure gauges that alert operators to dangerous climbs, safety valves that bleed excess steam before the vessel ruptures, and scheduled inspections that catch corrosion and cracking before they progress. All 3 require maintenance. In mills where production dictates the calendar, maintenance comes last. Coal combustion leaves mineral deposits called scale along the interior walls. Scale creates uneven heating. Metal expands and contracts under repeated thermal stress. Microscopic fractures develop along the seams where riveted plates meet. None of this is visible from the outside. To the worker crossing the floor, the boiler looks exactly as it always has: stable, warm, functional. The damage is internal and cumulative and silent. Every uninterrupted shift adds stress to metal that has already been stressed. Every postponed inspection allows fractures to widen by fractions that will eventually become fatal measurements. The boiler does not announce when it has reached its limit. It simply reaches it. By the late 19th century, boiler explosions are not rare events. They are a documented pattern, repeated across American industry with enough frequency that engineering journals publish formal warnings about them. Investigators examining failed boilers find the same conditions each time: corroded metal that has gone unrepaired, safety valves that stick or leak, pressure gauges that read inaccurately, operating pressures pushed beyond what the vessel was built to sustain. The causes are not mysterious. They are recorded, analyzed, and published. The industry reads these reports and continues operating. Workers notice things that inspectors sometimes miss. A sharp knock from inside the boiler casing. A steam valve that weeps constantly along its seal. A low vibration that changes pitch during peak load hours. These sounds and sensations are part of the daily vocabulary of mill life, and experienced men learn to read them as signals. But a worker who raises concerns about a boiler is not an engineer with authority to order a shutdown. He is a man whose wage depends on the mill remaining in operation. Steel furnaces do not cool quickly. Rolling machinery tied to a boiler's output cannot simply pause. Stopping production to investigate a sound inside an iron shell is not a decision most floor workers are positioned to make. So the scale continues accumulating along the interior walls, trapping heat unevenly. The metal continues cycling through expansion and contraction with every shift. The microscopic fractures in the riveted seams continue widening, invisibly, while steam flows through the pipes and the mill turns out steel on schedule. From the outside, the machine is performing exactly as required. What is happening inside the shell is a different matter entirely, and the gap between those two realities is narrowing. This is not one story. It is the same story, told in different cities, in different years, with different names on the casualty lists. Across the United States, boiler explosions tear through factories, rail yards, sawmills, and riverboats throughout the industrial era. Newspapers carry the accounts in similar language each time. A building reduced to scattered timber and bent steel, men killed instantly by fragmenting metal, survivors pulled from the wreckage with burns that cover most of their bodies. Some explosions destroy a single room. Others level an entire production block, leaving a crater where machinery once stood. Investigators arrive at the ruins and find conditions that have become familiar through repetition. Worn plate metal. Sheared rivets. Safety valves seized in the closed position. Operating logs showing the boiler had run continuously for years without a full internal inspection. Each incident is recorded as an isolated event. Industry does not treat the pattern as a pattern. Owners repair the structure, install a replacement boiler, and return to production schedules. The economic logic is direct and unspoken. The cost of comprehensive safety reform exceeds the cost of absorbing periodic disasters. Steel demand does not pause for investigations. Construction contracts do not extend deadlines for grief. Workers carry their own private accounting of the risk. In factory slang, aging boilers earn names that acknowledge what they are. Men who spend shifts within the blast radius of a failing vessel understand, in practical terms, what survival odds look like in an enclosed building when pressurized steel ruptures. They report for work anyway. Their families require the wages, so the boilers keep running. The pressure inside keeps building. The metal keeps weakening along seams that no inspector has examined in years. The next preventable disaster is already in progress. The mill does not exist in isolation. It generates a world around itself. Within walking distance of the factory gates, rows of modest homes line streets that exist because the mill exists. Boarding houses absorb the steady flow of immigrant laborers arriving from Eastern Europe, from Ireland, from the American South, all of them drawn by the promise of steady wages in steel. Small shops and taverns open near the entrances, their hours aligned with shift changes. The mill is not merely the largest employer in these neighborhoods. It is the economic foundation beneath everything else. The reason the street exists, the reason the church was built, the reason families settled here rather than somewhere else. The shifts run 12 hours. During heavy production cycles, longer. Workers move between blistering furnaces and the machinery those furnaces power, breathing air that carries the permanent smell of coal smoke and hot iron. Sweat dries before it forms in the heat zones nearest the rolling equipment. Children in these neighborhoods grow up calibrated to the mill's rhythms. Shift change whistles mark the hours. The low engine rumble carries through walls at night. Steam venting from pressure lines is as ordinary as weather. Danger is understood here, but it is understood as individual and manageable. Men lose fingers to machinery. Occasionally someone does not come home. These losses are mourned and then absorbed, because the alternative, leaving, refusing the wage, is not a realistic option for most families. The boilers behind the brick walls are part of the permanent background of this life. They have always been there. They have always worked. That assumption is about to cost this community everything. The disaster does not announce itself. It begins as a sound. Inside the boiler, coal fires have been driving pressure upward through the shift. Steam fills the upper chamber. The metal shell, compromised along a riveted seam by years of corrosion and scale buildup, absorbs the load the way it always has, until the point where it cannot. The deformation starts too small to see. Then the steel begins to tear. Workers on the floor hear a sharp metallic crack, short and clean, cutting briefly through the machinery noise. A few turn toward it. The sound is unfamiliar but carries no immediate meaning. There is no established signal in a steel mill for what is about to happen. The rupture spreads in fractions of a second. Thousands of gallons of superheated water convert to steam instantaneously. The expansion is violent and total. Steam volume hundreds of times greater than the liquid that produced it, seeking release in every direction at once. The energy involved is equivalent to a military explosive detonating inside a building full of men. Steel plates separate from the vessel and cross the mill floor at lethal velocity. Rivets become shrapnel. The blast wave hits before anyone can process what generated it, throwing men from elevated positions and driving equipment into walls. Superheated steam floods the immediate area. At its temperature, exposure is not painful. It is fatal. Wooden structural supports ignite. Coal dust suspended in the air finds the flame. Sections of the building begin to fail as the framework loses integrity. Men who are able try to move toward exits. The building is already coming down around them. The noise fades. The steam thins. The scale of what has just occurred begins to take shape in the settling dust. The blast wave does not stop at the boiler room. Through the mill the wave force always moves through enclosed space. Outward, into everything. Machinery bolted to concrete foundations tears free. Overhead cranes buckle against their rails. Every window in the facility shatters simultaneously, sending glass outward into the yard. The pressure differential is so sudden and so total that the building does not absorb it. The building transmits it. Boiler fragments continue traveling after the initial detonation. Some of these pieces weigh hundreds of pounds. They do not slow when they reach brick walls. They pass through them, carrying sections of roof beam and pipe fitting into neighboring structures. Workers positioned far from the boiler room are struck by debris that arrives without sound, without warning, faster than any human reflex. The explosion ruptures steam lines running throughout the facility. Scalding vapor floods corridors and secondary work areas through broken pipe ends, filling enclosed spaces with heat that renders them impassable within seconds. Wooden roof supports, never designed to absorb this kind of shockwave, splinter along their lengths. Heavy equipment drops through floors weakened by the structural failure above. Outside the factory walls, the neighborhood registers the event before anyone understands it. Windows crack in homes on adjacent streets. Residents step outside to find a column of smoke rising above the mill complex, dark against the sky. Inside, the men still standing begin moving toward the sounds of those who are not. But fires are taking hold in the coal dust and broken timber. Steam continues venting from pipes that no valve can now control. Collapsed structural sections block direct paths through the facility. The explosion lasted less than a second. The trap it has created will hold for much longer. When the fires are brought under control and the steam finally stops hissing through broken pipes, the men moving through the wreckage are no longer looking for survivors. They are recovering the dead. Rescue crews pick through collapsed roof sections and tangled machinery in air that still smells of scorched metal and burned coal. Some victims are found near the boiler site, killed by the initial rupture before they had any chance of movement. Others are located beneath fallen structural beams, or under equipment that the blast wave drove from its mountings. Several bodies bear the specific injuries of superheated steam exposure, burns that require no further explanation to anyone who understands what this boiler contained. The final count reaches 146 workers dead. These are men in their 20s and 30s, mostly. Immigrants who came to this industrial town because the mill offered consistent wages and the possibility of stability. Fathers whose families live within walking distance of the factory gates, close enough that the sound of the explosion reached their homes before any official word arrived. Entire shift crews are gone. Brothers who worked the same floor on the same rotation. Men who shared boarding house rooms and ate at the same tables. Funerals run consecutively for days. Black mourning cloth appears on doorways throughout the neighborhood. Church bells toll so frequently they cease to mark individual losses and become instead a continuous presence over the community. The economic consequences arrive alongside the grief. These households depended entirely on the wages that ended inside that building. Without that income, the question of how families survive the next month is not abstract. The boiler has not merely destroyed a mill. It has dismantled an entire community's foundation in a single shift. Engineers and inspectors arrive at the ruins of the mill with measuring tools and notebooks, and they find what the wreckage has preserved for them. They collect fragments of the steel shell and lay them out for examination. They trace the failure point along a riveted seam where corrosion has eaten through the plate metal over years of continuous operation. They document scale deposits on recovered interior sections, mineral buildup thick enough to have created dangerous thermal gradients across the vessel wall. Witness accounts describe the metallic groan that preceded the rupture by seconds, a sound consistent with a steel structure deforming under pressure it can no longer distribute evenly. The technical conclusion is reached with relative efficiency. Metal fatigue, accelerated by corrosion and scale accumulation, reduced the structural integrity of the boiler below the threshold required to contain its operating pressure. The vessel failed. The stored energy released. 146 men died. The mechanical explanation is accurate. It is also carefully bounded. The investigation examines the component that failed. It does not, with equal rigor, examine the system that allowed the component to reach that condition. The questions that would require that examination are present in the evidence but absent from the conclusions. Why did internal inspections not identify the corrosion at a stage when repair was still possible? What maintenance records existed for this vessel, and who held responsibility for acting on them? Who made the operational decisions that kept this boiler running beyond the point where its condition warranted shutdown? The final reports describe a mechanical failure. The decisions behind that failure are recorded as context, not cause. The file is closed. The mill begins planning its reconstruction. A boiler does not neglect itself. The decisions that leave a pressurized vessel running on corroded metal and missed inspections are made by people, inside an economic structure that consistently rewards those decisions. Steel mills in the early industrial era operate inside intensely competitive markets. Contracts carry delivery deadlines. Furnaces and rolling machinery must produce on schedule. Every hour a boiler sits offline for inspection or repair is an hour the mill is not generating output, and that cost is immediate and measurable. The cost of a catastrophic failure is deferred, uncertain, and distributed across workers, families, and a community that has no formal mechanism to recover it. So maintenance is postponed. Inspections are abbreviated or recorded without being fully performed. Boilers remain in continuous service well beyond the intervals that engineers, in published literature, identify as safe operating limits. Workers in these mills carry the consequences of decisions they do not make. Early industrial labor operates almost entirely without formal protections. A man who refuses an assignment on the grounds that nearby equipment is unsafe does not trigger a safety review. He triggers his own termination. The job goes to someone else. His family absorbs the result. This dynamic does not belong exclusively to steel. Across the industrial era, the same structure produces the same outcomes in mines, in textile factories, in rail yards. Equipment degrades past safe operating limits. Workers are present when it fails. Investigations describe mechanical causes. The economic logic that produced those mechanical conditions is noted and then set aside. The boiler that kills 146 men is not an anomaly within this system. It is the system made visible. Reform does not arrive with the rescue crews. It arrives years later, incrementally, and only after the accumulated weight of similar disasters across the industrial world makes continued inaction politically untenable. In the aftermath of preventable boiler explosions throughout the era, some regions begin enacting stricter inspection requirements. Engineers advocate for standardized safety valves and pressure gauges that can be tested and certified rather than trusted by assumption. Professional boiler inspectors, independent of the facilities they examine, become more common. These measures reduce the frequency of catastrophic failures. They do not eliminate them, and they arrive only after the deaths that made their necessity undeniable. The mill itself eventually reopens. New boilers are installed in place of the destroyed vessel. The furnaces return to temperature. Steel moves through the rolling machinery and out the factory gates. Production resumes its rhythm, and the industrial economy absorbs the disaster the way it absorbs all such events, as a delay, not a reckoning. The 146 workers do not resume anything. What their deaths leave behind, beyond the grief that reshapes the community around the factory, is a record. A documented instance of what happens when corrosion is left to progress, when inspection schedules are subordinated to production schedules, when the people closest to dangerous machinery are given the least authority over the conditions surrounding them. Modern engineering standards and regulatory frameworks have made industrial boilers significantly safer than they were in this era. That progress is real, and it matters that IT was purchased at a price that was never fairly distributed.